Jackson here. Hope you're all doing well. It's still May of 2021, which means it's still Electrical Safety Month. So we're going to continue our discussion on electrical safety, only this time we're going to change gears and go from 70E back to the NEC and talk about Article 590, which of course is temporary installations. All right, what we're looking at here on the screen is some very newly published data showing non-fatal work-related electrical injuries from 2003 to 2019. It always takes a couple of years to tabulate all of the values, and as of May 2021, this is the most up-to-date information that we have. This graphic is showing burn injuries and shock injuries that are work-related and non-fatal. And it kind of shows why I'm emphasizing temporary wiring and GFCI protection, because the fact of the matter is, when it comes to electrical incidents, the construction industry is still #1 for the most amount of shocks and the most amount of burns. So Article 590 talks about how to protect us from those types of injury. Now, this data is from 2003 to 2018, and I want to show this just to kind of indicate that, you know, it's not all doom and gloom. Sometimes we look at graphs like the one I just showed, and it's a downer and it's a buzzkill, and everybody says, oh, geez, you know, everybody's dying and the world's on fire, and look, that's simply not true. We are getting better and better every year. Take a look at this graph here. This is fatalities in the workplace from 2013 to 2018, and you can see we are very much headed in the right direction. So I want to make sure that we're clear on that, and that we don't just get beat up with all of these negative statistics over and over. So we're heading the right way in fatalities and non-fatal injuries as well. So you can see from 2013 to 2018, it's not quite as steep a reduction as the fatal injuries, but perhaps some of those that would have been fatal earlier now became just injuries and not fatal injuries. So yeah, this one's kind of up and down a little bit more than the fatal ones, but if the fatal ones go down and the non-fatal ones kind of hover around the same place, I can live with that. And maybe live with is a bad choice of words. The pun was not intended. But you know, if we're saving people from dying and we're getting less injuries, that is definitely a good thing, and I think it's worth talking about, because what we're doing is working. We can argue whether it's working well enough, but it is definitely working. All right, let's get into the technical side and talk about some of the rules. When we get into temporary wiring, of course, we're talking about Article 590. Article 590 applies to temporary wiring for electric power and lighting applications. All right, so a job site is probably the most common application for Article 590, although it's not necessarily limited to construction sites, but that's probably the most common use. 590.2 is a very important section, and to be quite honest, even if it didn't say this, the code still gets you there. When you use 90.3 in the NEC, it says, look, chapters 1 through 4 apply to all installations. And then chapters 5, 6, and 7 supplement or modify the general rules in chapters 1 through 4. And then, of course, we have chapter 8, which is for communication, and that kind of stands on its own. But for power and lighting, chapters 1 through 4 apply regardless. And then chapter 5 supplements or modifies the requirements. So all the regular rules for a permanent installation still apply. What Article 590 does is it doesn't really remove rules. It adds rules. And if you stop and think about it for a minute, it kind of makes sense. Where are you more likely to receive an electrical injury? You know, in your house with your consumer products, you know, your TV and your computer and everything, or out on a job site, you know, when you're working in the mud and you got cords running through puddles and everything else. You know, it makes sense that Article 590 is actually tougher to comply with than the regular requirements of the code. Now, there's a few exceptions. Some things in Article 590 remove requirements, but most of 590 actually adds requirements. You know what complying with Article 590 really does? Get you a lot of GFCIs. That's pretty, I've had people say, oh, it's just temporary. And, okay, well, cool. Now you need GFCI protection. You didn't before. So we take temporary wiring very seriously in the NEC, and for good reason. 90.2b approval. Temporary installations must be approved, which is acceptable to the authority having jurisdiction, based on the conditions of use and any special requirements of the installation. It's hard enough to write code that covers every conceivable condition. We have to have a one-size-fits-all code book that applies to everything, and that's pretty difficult, especially when you throw in things like temporary conditions, rain and snow and everything else. So it does have to be approved, and it doesn't quite tell us exactly how to do this. It leaves a lot up to the inspector, to the authority having jurisdiction. For example, here's a picture that an inspector friend of mine in Salt Lake City sent me, and yes, this is a real picture. She sent me a text, and she says, "You will absolutely not believe what I saw today." And of course, I hear that fairly often, and I'm thinking, okay, I certainly haven't seen everything, but I've seen some pretty dumb stuff. And she goes, "Well, this might be the #1 on your list. Take a look." And this is what it was. They actually, this is in the middle of winter, they were supporting their temporary pedestal with a bucket of ice. So, just pour some ice, just pour some water in there, and, it's Salt Lake in January, it's going to freeze, This kind of puts like a time limit on it, you better be done with the project by April or your temporary power is going away. But, stuff like that, obviously the NEC doesn't exactly address. It leaves it up to the AHJ, and for good reason. So suffice it to say, she didn't pass this inspection. Time limits, 90.3a. It's kind of funny. A lot of people, when you talk about temporary wiring, the number 90 comes up as, oh, you got a 90-day limitation. No, you have a 90-day limitation for holiday lighting, like Christmas lights that you might have out in your front yard. That's where a 90-day limitation comes in. When it comes to actual construction activity, there is no time limit. I mean, think about it. How many buildings, really get built in 90 days? Maybe small residential and small commercial, but if you're doing anything, even somewhat complex, 90 days just isn't going to do it. So there is no time limit as far as construction activities. You can have your temporary wiring up as long as you need it, but if we keep reading and we go to subsection D, it does have to be removed once the job is complete. So 590.3D, temporary wiring must be removed immediately once construction or a similar application is completed. Now, I took this photograph, and this would have been back in maybe 2002, I think. And this was at a job site. I shouldn't say this, but I will. This was actually at our city hall, at the city that I worked for at the time. We built a new building, and we had just occupied it, right? We just finished everything up, and you can see it was maybe February or something, a little bit of snow on the ground, not much. And I was leaving the office to go do my inspections for the day, and I saw this, and I slammed on the brakes, and I couldn't get my camera out fast enough. Fortunately, I actually had a digital camera with me because, 2002, we didn't have camera phones. And I was able to snap some pics of this. But what it was this is where the construction trailer was for the job site, and this, of course, was the temporary power. And they moved the trailer away, and they brought up the grade, like 3 feet or something. They put in like 3 feet of dirt and buried this temporary power like halfway up, and then proceeded to plant sod around it and everything else. It's like, hey, who's taking care of the temporary power? Not my job. So yeah, we need to take this stuff out once the job is completed, and it makes sense that we need to do that. So having kind of established some ground rules for temporary wiring, let's talk about the GFCI protection, the reason that we're here. It's important to remember what GFCI does, why we use it. GFCI does not prevent electric shocks. It prevents most electric shocks from being a fatal electric shock. You can still get shocked on a GFCI, but it'll open the circuit before you die. right? That's the idea of a GFCI. So a GFCI does one thing and one thing only. It keeps people from dying. That's the whole reason they exist. So for construction, remodeling, maintenance, repair, or the demolition of buildings and structures, GFCI protection must be provided in accordance with 590.6 A and B. All right, so A talks about receptacle outlets. Receptacle outlets must have GFCI protection in accordance with A1 through A3. All right, so A1 talks about receptacles that are not part of the permanent wiring. So this receptacle here, I've got my 480 volt panel, my transformer, my 208 volt panel. I've got all of these receptacles on there. These are obviously not part of the permanent wiring. So all 125 volt, single phase, 15, 20, and 30 amp receptacles that are not part of the permanent wiring of the premises and that are used by personnel must be GFCI protected. Okay, so if it's temporary and you've got receptacles and those receptacles are being used for persons for activities like remodeling, repair, building, demolition, etc., they have to be GFCI protected. If you keep reading, it also says that in addition to that protection, listed cord sets or devices that incorporate listed GFCI protection for personnel that are identified for portable use are allowed as well. All right, so we have to have GFCI protection for the receptacles that are not permanently part of the building. And if you would like, you can also add more GFCI protection in the form of these guys as well. It talks about being identified for portable use, and part of what that means is that it has open neutral protection. So if you lose the neutral, it will open the GFCI device. Let's keep reading. Permanently installed receptacles. So why am I showing this in the picture? Well, this house, as you can see, is 99% of the way finished, but I was there doing an inspection. I mean, the job isn't complete until it passes final inspection, in my opinion. So could the painter, be plugging in equipment to these receptacles? Yeah, sure, of course. Finished carpenters, all of those people. So what's the rules for permanently installed receptacles? Well, all permanently installed 125 volt single phase, 15, 20, or 30 amp receptacles must be GFCI protected if they're being used by personnel. Okay, so it doesn't matter if they're part of the building or not part of the building, we have to have GFCI protection. But if you read in this section, it's written a little bit differently. You see, in A1, the receptacles that are not permanent, it says, hey, you have to have GFCI protection. And in addition to that, you can use portable devices. Well, it's worded a little bit differently here in A2. It says, listed cord sets or devices incorporating listed GFCI protection for personnel identified for portable use are allowed. It doesn't specify that that's in addition to the required protection. You could read this and easily argue that this can be used in lieu of the required protection. So in other words, I could look at this and maybe I wired the house, I'm the electrician. I have to turn everything on for the final inspection, but I can't possibly be expected to know which receptacles all of the different tradespeople are going to use. I don't know where you're going to plug in your radio. Give me a break. So am I supposed to GFCI every receptacle in the entire house because they might be used during construction? I don't think that's really, if we're being honest, I mean, I don't know how you could be expected to do that. So maybe you can leave a note and say, look, the receptacles in the kitchens and bathrooms, you can use those for construction. Or maybe you read this part of the code and you put it into your contract and you say, listen, receptacles that are permanently installed, GFCI protection is to be provided by the individual contractors. We will provide temporary power for receptacles that are not part of the building. And receptacles that are part of the building, your contractors are expected to provide their own protection. And we could use this language here in the code and probably justify that position. So this one seems to be allowing those devices instead of the protection of the receptacles. And again, I'm not positive that that's intended or not, but the two sections definitely read different. If we keep reading, we have rules for receptacles on 15 kW or smaller generators. all 125 volt, 125 volt, and 125/250 volt receptacles that are single phase, 15, 20, or 30 amp. Those must be GFCI protected if I'm using those for temporary wiring. So beautiful thing, all of these are GFCI protected, and we're in good shape that way. Listed cord sets or devices incorporating listed GFCI protection for personnel identified for portable use, or allowed for generators that were manufactured before 2011. So I remember vividly when this section came into the code, and there was a very big debate about portable generators and GFCI protection, and whether the neutral should be bonded to the frame of a portable generator, and if you do that, could you use it for a standby system? And this was a big discussion back 10 years ago, huge discussion. At the end of the day, generators manufactured before 2011, they didn't really employ GFCI protection because the neutral was floating. The neutral wasn't bonded to the frame of the generator. And if it's not bonded to the frame of the generator, then a GFCI wouldn't really work, because it's kind of an, I don't want to use the wrong terminology, but it's kind of an ungrounded system. And when I say ungrounded system, I'm not talking like a 2-wire house, you know, from 50 years ago. An ungrounded system is something completely different. So back then, before 2011, you didn't really have GFCI protection on portable generators. Sometimes after the 2011 code change, it became mandatory. 590.6b talks about other receptacle outlets, and you can see the highlighted underlined text there, the word receptacle. It used to say other outlets. Okay, well, you know, an outlet is not limited to receptacle outlets. Lighting outlets and hardwired equipment ultimately are connected to an outlet by definition, but we're talking about other receptacle outlets. Okay, well, other than what? Well, other than 125 volt, single phase, 15, 20, or 30 amp. Okay, so those ones, you got to have GFCI protection, period. That's the rule. Other receptacles, like the one here in the photograph, this 250 volt, 50 amp rated receptacle, those also have to have GFCI protection, or a system that we call the Assured Equipment Grounding Conductor Program. So let's start with option 1, which is GFCI protection. You got to have GFCI protection. This is GFCI breaker for this 250 volt receptacle that is absolutely required. It's been required for at least 20 years off the top of my head. I know when I travel around, there's a lot of places that don't realize that this is a requirement and has been a requirement for a very long time. So looking at this photograph here, this would be a violation. Right here we've just got a regular old 2-pole 50, and we've got a 50 amp receptacle, and yeah, that's a violation. That thing needs to have GFCI protection. I want to point out something that was in the code for only 3 years. In the 2017 code, they added language about what we call special purpose GFCI protection, and then they took it right back out in the 2020. So special purpose GFCI protection is GFCI protection that falls outside of the boundaries of what we call Class A GFCI. And Class A, anytime in the NEC, anytime we have a GFCI rule, it has to be a Class A device, because that's part of the definition of GFCI. And a Class A device means that it opens at currents greater than 4 to 6 milliamps of leakage current. So it will stay closed at leakage currents less than 4 milliamps, and it will open at leakage currents of more than 6 milliamps. A special purpose GFCI can trip at other ranges and in other and the what do you call it? The voltage is different, and also the response time can be different as well. So special purpose GFCI, does it protect people? Yeah, but it's better than nothing. You know, it provides more protection than a regular circuit breaker. But sometimes we're talking about you know, trip points that are greater than the maximum Lechtel threshold. So a special purpose GFCI, it would stop you from dying, but it would still allow you to get hung up on the circuit and receive a very painful shock, and it wouldn't necessarily protect children from dying. So we had language about special purpose GFCIs. It survived 3 years and then was removed immediately in the 2020. So we have to have GFCI protection pretty much for all receptacle outlets. I said that there was an or, however, right? Receptacles other than 125 volts, single phase, 15, 20, or 30 amps have to have GFCI protection, or the Assured Equipment Grounding Conductor Program. Now listen, I don't like to tell people what to do. If you want to do an Assured Equipment Grounding Conductor Program, have at it. Have fun. I'll tell you this. Speaking with OSHA representatives, OSHA recognizes this as well, but they write people up for it all the time. The people that I know that I've talked to that work for OSHA say that, look, usually when someone chooses the Assured Equipment Grounding Conductor Program as an equivalent or as an alternative to GFCI protection, usually they do it wrong and we end up citing them. So do this at your own peril. I can tell you as someone that's worked as an expert witness on a few different electrocutions, you know, if somebody really got injured or killed, sometimes in a civil lawsuit, the absolute requirements of the law is one discussion point, but best practices and industry standards and standards of care, those things get brought up as well. If somebody got killed or severely injured on a job, I don't think you'd want to tell the attorney that, yeah, you knew GFCI protection would work and it's the safest method and the most effective method of preventing fatal electric shock that we have. I knew all of that, but I wanted to save $50 and use this thing. You know, that's probably not a discussion that you want to have. So again, I'm not telling you what to do. You want to use the Assured Equipment Grounding Conductor Program, go ahead. The code recognizes it, OSHA recognizes it, but please make sure you do it right. Look at OSHA 1910 and 1926 and make sure you're following everything correctly. So, in lieu of GFCI protection, a written Assured Equipment Grounding Conductor Program that is continuously enforced could be used and has to be documented and be available to the authority having jurisdiction. So looking at this photographs, and look, I'm just going to be perfectly honest. I just grabbed a couple of cords from my garage, threw them on my grass, and you know, measured continuity a couple of years ago when I took this picture. Let's talk about this for a minute. These are 120 volt, 15, 20 amp cords. So GFCI protection is required for those. The Assured Equipment Grounding Conductor Program is not an alternative to conductors of that voltage and that current. We're only talking about receptacles that are not 125 volt, 15, 20, or 30 amp. So if I had a 240 volt cord that I was going to plug into a 250 volt receptacle and I didn't want to have GFCI protection, then I could perhaps utilize the Assured Equipment Grounding Conductor Program. Got to make sure it's continuously enforced, it's got to be documented, has to be made available to the AHJ, and then there is an informational note as well that says, listen, OSHA 1910 and 1926, as well as NFPA 70E, the standard for electrical safety in the workplace, they all reference the Assured Equipment Grounding Conductor Program. But again, at the end of the day, I think we all know that GFCI protection is probably a better solution, but it is recognized to use the Assured Equipment Grounding Conductor Program as well. All right, with that said, we made it through the GFCI requirements for temporary installations. Please be safe. Please use your head. You know, the number one most important thing of any safety program is you, and people that are willing to follow the program and care about it. So make sure you're being safe. You deserve it. Your family deserves it. And we'll see you next time. Hope you guys got something out of the video. Take care, everyone. Thanks. Be sure to like, follow, subscribe, and ring the bell.